Yes, I am audible to you.
Yes, sir. Hello.
Yes, video on कीजिए.
Okay. Good evening, sir.
Yes, good evening. Yes, have you complete all the point regarding laboratory part?
Yes, sir. I have completed. I have read about things.
Okay. Yeah, let me start first of all. Basic introduce yourself.
Okay. Good evening, sir. Myself Simran. I am from Rewari, Haryana. I have done my class 10th and 12th from there only. My In my 10th, I have 10 CGPA. Then in my 12th, I have 97 percentile with a perfect 100 in chemistry to College University of Delhi for my. I have written the JAM exam and I have joined the Indian Institute of Science as an integrated PhD student. So currently, I'm a, PhD student, third year PhD student in Indian Institute of Science.
Yes, good. Yeah, let's move on laboratory part. Yes, what the role of laboratory in your life, and what are the basic applications of laboratory?
So being a PhD student, lab is the only constant in my life from past 3-4 years. So lab is for me, it is basically platform to create new things and to take the textbook level information in the real world and to look the applications out of the textual reactions which we have read till date. So that's what I understand about the laboratories.
Yes. Next is laboratory. First basic point is qualitative and quantitative analysis.
Yes, sir. Sir, if I have to distinguish between them, then the name itself is quite distinguishing. Like qualitative analysis means that you're trying to get to know about the quality of the compound which is being given, which means like we want to know what is the composition of the compound which is being given, like what are the elements which are being present. So this is about the qualitative analysis. And about quantitative analysis is to get to know how much any substance is present in any compound which is being given to us. So this is the major difference between qualitative and quantitative analysis.
Yes, qualitative first basic point is elemental analysis. What is elemental analysis?
Sir, basically, elemental analysis is to get to know about the elements which are being present in the compound, with the help of which we can get to know about the formula of the compound. Like if a compound is being given to us, then how much carbon is present in it, how much sulfur is present. So this is if we get to know about these things by some test, we call it as an elemental analysis.
Yes, elemental analysis first before the basic point is sodium extracted solution, Lassine solution. How to prepare, how to make it?
Solution, this I don't have idea like how to prepare sodium.
To detect
Like,
nitrogen in a lab. This test is follow.
uh,
Nitrogen.
this that is Kildal method is there, in which we take the compound and we try to convert the nitrogen into the ammonia, and then with the help of titration we get to know about the amount of the ammonia which is being there. So if we see the back of it, then we get to know about the nitrogen present in the given compound.
Yes. Next is sulfur. Test for sulfur. How to detect
Sulfur. Yes, sir. For sulfur, there is a curious method. Maybe I'm not pronouncing it well, but in this, we react sulfur basically the oxides, and then we get to form the PPTs, out of which we get to know about the content of the sulfur which is present in a given compound.
sulfur test is lead acetate test. Black PPT will be
Uh,
there. Next is
oh, okay.
sodium nitroperoxide test. Red is yellow color.
Oh, okay, sir. I will look into it.
Yes, you look them, you have to study.
Hmm.
The next is test for nitrogen and sulfur present together.
Okay, these also I have to see, sir. Like basically, I have seen just the basic elements like carbon, nitrogen, and all of these things. Then the trace elements which are being present. So I will
The
look into
test with
detail.
the FeCl3, blood
Huh?
red blood. Test with FeCl3.
Okay, okay, sir. I will read about it.
Yes, the halogen test. Test for halogen.
Yes. For halogen, we make it them react with AgNO3. Then we get different PPTs like with fluorine. I guess fluorine, chlorine, bromine. Huh. Then with fluorine, we get a PPT which get soluble with ammonia. I guess. Then with like AgCl is formed, that will also form a PPT which is partially soluble. Then we have AgBr which is completely insoluble. So with AgNO3 we try to get to know about the halides.
Yes. Next is functional group. How to detect functional group in a lab?
Like sir, there are different methods which are proposed for different type of functional group. Like starting with alcohol, if I talk about, then Lucas test is there if we want to distinguish between the primary, secondary, and tertiary alcohols. Other is ferric ammonium nitrate test. I guess for this alcohol. Then if I talk about aldehyde, then Tollens test and Felling test is there. If about I talk about carboxylic acid, then like sodium hydrogen carbonate, we react with that. Then evolution of carbon dioxide is the indicator. Also, litmus test can also be done with. If I talk about the ester, then first thing is ester is fruit has fruity smell. That is one part. Also. We can do its hydrolysis, which can give us the test for the acid after the hydrolysis. So that is another test. For ammonia, there is Heisenberg test and carbalamine test, which will carbalamine test, which will produce carbamate, which will produce the foul smell. So with that, we can get to know about the ammonia. So yeah, these are the basic tests I remember right now for different functional groups. And for unsaturation, also there is a test with KMNO4, like the decoloration of the KMNO4 will indicate us that there was unsaturation present in the compound. So that is another test which I remember right now. And phenol, there is a test like 2,4-DNP test is there for phenol. So that is another test which we have. And if I talk about ketone, that also I think it will also give us 2,4-DNP test. Also, if it is a like it have a methyl group in ketone, then that iodoform test will also work.
Yes, aldehyde ketone.
Yes, sir. Aldehyde ketone, like Felling test we can do for aldehyde, like getting to know if it is aldehyde or ketone.
Yes.
Ketone will not give Felling test or the Tollens test. Silver mirror test, which is like known.
Yes. Alcohol.
Alcohol, it's a Lucas test we can go for, and ferric chloride test is there, I think. Lucas test is to distinguish between primary, secondary, tertiary alcohols.
Yes. Ester test.
Ester is basic hydrolysis can give like with the basic hydrolysis we can get to know about the esters. Also, uh, I think there is a test hydroxyme, like we make ester react with hydroxyme, then the compound which is formed it with the Fe+3 ions, it gives us a complex, colored complex. With that also we can get to know about the esters which has been present. Or normally also with the smell also we can get to know about the esters. Esters have fruity smell, so with that also we can get to know about if something is ester.
Hydrocarbons.
Hydrocarbons, like basic test with chlorine, only we can get to know about the hydrocarbons in presence of light.
Next is nitro compound.
Uh, Nitro compound, I read about it, but currently I'm not getting what was the test.
Nitro is Mulkan worker test.
Yes, maybe yes. I read about it, but I just forgot.
Amine test, primary, secondary, tertiary.
Heisenberg test can be done to distinguish between primary, secondary, tertiary amines. And in general, amines can be distinguished by the carbylamine test, that it will form the carbamate, which have a foul smell.
Yes. amide test.
My test, uh, I don't know. I have to read.
Amide is wide rate test. Wide rate.
Okay, I'll read about it, sir.
Next is boiling point and melting point. What the basic difference and what the example?
Okay, basically, if I in general, if I talk about, then boiling point is liquid going from like a liquid going to the vapor state, gaseous state. We call the temperature at which liquid goes to the vapor state. We call it as a boiling. And if a solid is being converted into liquid, that will be called as melting. And in scientific term, if I talk about, then boiling is changing liquid to vapors, the temperature at which liquid is being converted, the temperature at which liquid vapor pressure is being equal to the atmospheric pressure, we call it as a boiling point. And if I talk about the melting point, then the solid vapor pressure being equal to the liquid vapor pressure, we call it as a melting point.
Yes, good. The next move on. Next point is third is volumetric analysis. Yes, what is volumetric analysis?
Volumetric analysis is basically to get to know like how much substance is present. Like it's a quantitative analysis. So there are different types of volumetric analysis with which we can get to know about the like amount which is being present in a given analyte. So we titrate the analyte with like there are different depending on the nature of the analyte. There are different types of volumetric analysis are there. Like acid-base analysis is there. Complexometric titrations are there, or precipitation titrations are there. So depending on the nature of the analyte, we will decide. And let's suppose if there is a base, then we titrate it with the acid. It will show us like the end point of a reaction. So with that, we will like the amount of titrant which is being used to neutralize, or we can say to get the endpoint in the analyte. With that stoichiometric comparison, we can get to know about the amount of the substance which is being present in a given analyte.
Yes, volumetric titration and indicator. These are two basic points. Yes, titration. How
Uh,
many types of titration?
Yes, sir. Acid-based titrations are there, complexometric titrations are there, precipitation titrations are there. So, redox titrations are there. So, if there is acid or base is present, we use acid-based titrations. If there is metal ion which can be present in different oxidation state, we can use the redox titrations. And for complexing like calcium, or if we want to get to know about these ions, then we can use the complexometric titrations. And precipitation titrations are also there if like we let's suppose we want to get to know about the chloride ion which are being present. So for that we can use the precipitation titrations.
Yes. Next is indicator. What is indicator and how many type of indicator?
Indicator is basically the substance which can give us idea about the endpoint. Uh, so let's suppose like in terms of acid, like acid base indicators are there, redox indicators are there, complexometric titration for complexometric titrations indicators are also there, like EBT is one of the complexometric indicator. So like in acid base, the indicator which will give different color on different pH level, we say those indicator will be, we call them as acid base indicators. Like phenolphthalein is one. In acidic, it remains colorless, but once that medium become basic, it start giving pink color. So with that, we can get to know about the endpoint. So that is there. In for complexometric, we have our EBT is there, which gives us uh, different color. I think blue black color it gives. So that is another indicator. So indicator are basically the uh, compounds which can help us to get to know about the endpoints.
Yes, good. Next, move on. Point number 4. Yes. Gravimetric analysis. Yes, what is gravimetric analysis? Gravimetric analysis,
Uh,
first basic things is precipitation.
Yes, sir. Sir, basically, gravimetric analysis is also a part of quantitative analysis. In this, what we do is, whatever the compound is being given to us, we make a precipitate out of it. Then we weigh the precipitate, first we precipitate it out, make a precipitation out of it. Then we filter the compound which is being present, we dry it, and then we take the mass of it. With the mass which we got, with that we back calculate according to the stoichiometry of the compound, that how much compound was there. If I compare it with the volumetric studies, then it is a quite precise analysis, better than the titration, like normal titrations which we use, like the volumetric analysis. It is easy. So these are the plus points of the gravimetric analysis. But yeah, both are the quantitative analysis.
Yes, first basic is solution. What is solution and how many type of solution?
Solution is basically the homogeneous mixture of solute and the solvent. Now, depending on the type of solute, the phase of solute and solvent, there are different type of solutions which we study. First is solid solution, that is in which both the solute and solvent are solid. The example is alloys. Then the other, if we the normal solution, which in general we call things as solution, is solid in liquid. The example is NaCl in water. Then another example could be liquid in liquid, that can be alcohol in water. The other thing is gas in gas, that is air is the prime example of it. Then we can have suppose solid in gas, then the iodine vapors could be one example of it. Then we can have solid in liquid. I think emulsions are one of that example. So, depending on the different solutions,
Yes.
getting
Good.
remembering right now.
Yeah, next move on point number 5. Point number 5 is instrumental analysis. Yes, what is instrumental analysis? And which type of instrument
Uh,
you have used in your academic career? Describe.
okay, okay, sir. Sir, instrumental analysis, like basically we are using the instruments to get to know about the knowledge about like which compounds are present, in which amount they are present, in which phase they are present, in which unit cells they are present, and what is the shape of the compound. So depending on our need of the experiments, we do different types of instrumental analysis. The prime instrument which I know is the XRD is one of them. Basically for the solid state compounds, XRD is a very good method which can tell us about the unit cell. It can tell us about the ABC parameter of the unit cell. It can tell about where the atoms are sitting. So these are the compounds which we can get to know about the with the XRD. And the other instrument which I use is UV, IR, NMR. NMR I don't use right now in my research, but like I have read it in my master's. I have used it in my master's project. Not project. In my master's, I have normal lab. So in there we have done. So IR is there with which in which every bond have a special vibration. So with those vibrations, we try to get to know about the functional groups which are being present. So for UV, there is the band gap which is present. So we basically we excite the electrons. So with that we try to get to know about the band gap of the compound. So with that we get to know about the knowledge of the compound which is being present. Then NMR is there. The NMR also, there is a multiple type of NMR. Majorly hydrogen and MR is there. So with which like combining the information we get from the IR, UV, and NMR, we try to fabricate the whole structure of the compound. So NMR is there. Like with NMR, we get to know about like if the hydrogen is primary, secondary, or it is attached to any nitrogen or oxygen. So these information we can get from the NMR. I have also used SEM. So SEM tells us about the like type of particles in which the compound is. Like it is a layered compound, it is a needle shaped particles are there. So about the type of particles which are being present in the sample which is being done. So that information we can get with the uh, SEM. With the SEM we can also get to know about the homogeneity of the sample. Like we can get to know if like if we have done some doping, so if it is concentrated or it is like homogeneous mixture is there, that we can do with the EDS. Also with the SEM only we can get to know about the thickness. Like if we have made any thin film, so thickness of the compound we can get to know about the SEM. If I then we have XPS. With the help of XPS we get to know about the oxidation state of any at metal, ion, or whatever ion is present in the compound. So in which oxidation state the elements are present. For that we use XPS is being used. So this is the another instrument which I used on regular basis. Also, I have read about AFM, which I haven't used in my research till date. But yeah, AFM is there with which we can get to know about the thickness of the film which is being made. So that is another technique we know. And majorly, I work with the photoluminescent materials. So photoluminescent studies also I do. So for that, we use the PL spectrophotometer. So that is the another instrument I know. So majorly these are the instrument. Now I'm like remembering whichever I have used. So yes, sir, these are the instruments.
Yes. Chromatography. Have you used chromatography in HPLC?
Uh, I haven't like I have used it in my bachelor's as much as I remember. But now as I'm not in a organic lab, so I haven't used chromatography as such. But yeah, I know basic principle of chromatography. There are different type of chromatography. Ion chromatography is there, in which we have reagents which have specific charge. So for specific ions, like the reagents will attract those ions. So with this we can get to know about the amount and about the different ions which is being present in the given compound. Then gas chromatography is there, in which we use the mobile phase which is being in gaseous state. Then we have stationary phase of silica and all. So we pass the sample. Then with that, like based on the boiling point, we get to know about like what are the compounds. Like based on the boiling point, the compound is gets separated in different layers. So with that, we try to get to know about the amount and try to separate the different elements present in the given compound which is being given to us. Then we have HPLC is there. So in this, the mobile phase is liquid, and then we have a column packed of silica or alumina. So based on the polarity, we try to segregate the different elements present in the given compound.
Yes. The next move on basic part of spectroscopy, ICP, OCS. Have you used ICP, inductivity coupled plasma?
Sir, I haven't used it, but I know the basic principle of it. I have read it in my master's also. So in this, what we do is we try to nebulize the sample which is being present. Means like we try to make thin fog-like particles out of it. Then the compound is being excited. The atoms and ions are being excited with a particular wavelength. Then those ions or atoms are de-excite, and then they leave a particular wavelength, and with that wavelength we try to get to know the information about the ion which was present, and with the intensity we try to get the information about the amount of the ion which has been present. If I talk about the in the urea, like in fertilizer industries, it can be used to get to know about the trace elements which are being present, so like present in the urea, so to get to know about the micronutrients present, we can use the ICP.
Yes, good. Yeah, next move on NFL section. NFL, yes, what the basic application of NFL? How it is work in our country, India?
Sir, basically, NFL is the National Fertilizers Limited. It is a PSU, that is a government-based company. It is a mini Ratna company. So, like how it works, like it basically it is, I guess, it is the second largest producer of urea. So basically, it produces urea. Uh, Also, like in urea, also after 2015. Uh, we produce neem coated urea for better efficiencies. So and there are multiple benefits of neem urea also. So basically NFL produce neem urea, then it produce other like side effect byproducts also, which are being sold as a chemical compounds, which are like ammonia is there, some bicarbonate compounds are sorry, alcohol is there, some bicarbonate compounds are there, some nitrates also there, and along with that it also sells seeds and all. So these are the like also in terms of fertilizers, it also have biofertilizers and compost fertilizers. So these are the like major part or major job of the NFL as a uh, mini Ratna company. So yes.
Navratna company, not Mini Ratna. Navratna from is
Oh,
November 2024.
oh, okay, sir.
Yes, NFL is PSU. What is PSU and how many companies working as a PSU in our country?
Sir, PSUs are basically public sector units. Like the companies, these companies are majorly handled by government. Like they have more than 51% of the shares, which are to the government only. But they combine collaborate with the private sectors as well. So that's how we define the PSU. Like the public sector and the private sector come working together. We call them as a PSU. So about how many PSUs are there, I'm not sure of.
Yes,
I'm
Maharatna,
with the exact
Navratna,
number, but
Mini
yeah.
Ratna. Yes, 14 Maharatna, 22 Navratna, and Mini Ratna is two category, Mini Ratna 1 and Mini Ratna 2. So 14 Maharatna, Navratna 22 or plus
Mm.
73 Mini Ratna. Total is 109.
Okay. Okay, sir. Okay, sir.
Yeah, next is NFL is fertilizer. Is what is fertilizer? And next is NFL brand name is fertilizer is Kisan.
Yes, sir. Fertilizers are basically the supplements which are needed by the crop for their better growth and for better their growth and production. So like it is composed of micronutrients basically we provide with our urea. So like nitrogen is the macronutrient which is needed by the plant, so we provide that with the help of urea. So fertilizers are basically the compounds which helps in growth and better production of any crops.
Yes, good. Next is why you want to join NFL as a product
uh,
post. What the role of the post in NFL?
Yes, sir. About the role of the post, it is like basically management things, Managing the safety protocols is one of the aspect of it. Checking the instruments, like if they are working fine or not, checking the like quality, like assisting the senior engineers to see the quality assurance is one of the work, if that is being fine or not. So basically it's management and checkmates which is being done by us if we will be get selected for the post. And the next part is why I want to join is, if I be honest, uh, then the answer is that, and if like it is a government job, so that's the main thing why I want to join here. And along with that, if I talk about it's one thing, it's a government job, and another thing is it is totally connected to my field, that is the chemistry. So like I never wanted to leave my subject as such. I have spent enough time over the subject, so this company will provide me to keep in touch, be in touch with my subject as well, and uh, join as a permanent job. So that's the reason and motive behind joining the NFL.
Yes, good. The next is water treatment. What is water treatment?
So basically, like there are different issues which can be with the water. Or we need to recycle the water, so that that part also we can include in the water treatment. So first is the hardness of the water. So like calcium and magnesium amount present in the water decide the hardness of the water. So hardness can be divided in two ways, like permanent hardness and the temporary hardness. So permanent hardness is the one which we can remove just by the simple boiling. So in this, calcium and magnesium bicarbonates are being present, so they get removed just with the boiling. I think they form the carbonates which just settle down. So that's one part to remove temporary hardness of the water. Then we have the permanent hardness, which arise from the ions like calcium and magnesium chlorides and sulfates which are being present in the water. That is the mm, I permanent hardness, which can be removed by the chemical treatments only. Other part is the alkalinity of the water, the pH of the water. If it is acidic, we need to neutralize it, and if it is basic, then also we need to make the pH in a optimum level. So that is the another issue. Then we have salinity is the another issue which we face, that is the amount of fluoride ion which is being present. So by the treatment with the AgNO3 or something, we can just take care of the fluoride level present in the water. So these are the parameters which one need to take care while dealing with the treatment of water, to make it again suitable for use.
Yes. Yes, soft water, hard water. Yeah, how to remove hardness from water?
Yes, sir. I just now talked about, there are two types of hardness which can be present in water. One is permanent hardness, and another is temporary hardness. So to deal with the temporary hardness, first, how why the temporary hardness come is because of calcium and magnesium hydrogen carbonates. Temporary hardness is being generated in the water. So if we just simply boiling, we can remove it. So we call it as a temporary hardness. Then another is permanent hardness, which is present because of the calcium and magnesium chlorides and sulfate ions. This is the hardness which can't be removed by just boiling. We need to treat them chemically, so we call it as permanent hardness.
Yes. Next is urea. What the basic application of urea and how to use it?
Urea, yes, urea is basically a macronutrients which is being used for the crops. So yes, so for the proper growth and development, urea is needed. Now, how it is being used in the crops is what is the chemical process behind it is like when we just sprinkle the urea, it is being converted into ammonia, then which is being reacted with the produce ammonium ion, and then ammonium ion and also nitrate. So plants consume ammonium and nitrate ions, and then these ions are being taken up with the plants and then helps in the growth of the plants. So this is the cycle which is being taken place outside, like in from urea to the essential ions which can be consumed by the plant. So this is a process of that, and then it can be used in different ways by the plants. Like nitrogen is the essential element for amino acids, which is needed for a proper growth. So and so yeah, these in this way, urea is being used for the plant growth and development.
Yes, good. Next is, suppose if you get selected in this post, so what do you do in your department? Now, how will you change in your department?
Like mine post is majorly a management job. So I'll try perform whatever the activities which has been assigned, which will be assigned to me in a sincere manner. I'll try that every protocol, every safety protocol is being manifested in a right manner, so that any mishappening should not happen, like to stop any mishappening to happen. So that will be my work. And another uh, like assisting and all, like being a person from like who have a well enough experience in laboratory, so I can help my seniors well in quality analysis and all. So that could be in this way also, I can use my knowledge to like see the effects better. So these are the things I feel I will be able to contribute.
Yes, good. Next is, you have lot of knowledge in your MSc project subject, in your PhD topics. So how will you contribute your knowledge in your department?
Sir, if I think of that right now, uh, like my PhD topic and my master's topic was completely different from the work maybe which I will be doing here. But the only contribution I can have is like I have a better lab experience. So I know how to run a lab. Like I'm a third year PhD student right now. So we are working independently from last almost 2 3 years. So I have that experience, so I can use that experience well. I am well aware of the safety protocols which one should follow while dealing with the chemicals. So that is one thing I'm well aware of. Also, the other safety protocols which should be there in any laboratories, I am well aware of all of those protocols. I am well aware of how to uh, take care of like a storage and disposal of waste. That is also one thing which we religiously follow here. So that is also one aspect I am already aware of. So that there also I can contribute. Not as per like my totally my project knowledge I won't be able to use, uh, but maybe the experience I have in terms of handling a lab, that experience I can have in a better manner. Also, being a PhD student, being a third year PhD student, I have also helped student like juniors in handling the projects, like in helping them learning different things and handling the instruments. So in that terms also, I think I have leadership qualities in terms of handling a team. So that also I feel I can do better. So these are the qualities I feel can be helpful for the organization if I have been selected.
Yes, good. Yeah, next move on water. Soft water and hard water. What the basic difference? And what the basic difference between pH of water? Drinking water, RO water, groundwater, surface
Mm,
water, canal water.
I am not aware of exact pH of it, but like as much as I know, it should be neutral.
Yes.
And about the RO water, I know a bit that it is slightly acidic in nature, which is in like appropriate amount only that one can consume. So that's the only thing, but exact pH values I don't know at this moment of time.
Yes, water is neutral, 7. And different
Okay.
type of RO water. Alkaline water is more than 7. Zinc, copper type of RO water is more than 7. Yes.
Okay.
Canal water is basic.
Okay.
Groundwater